the beautiful planet of life Earth. When you look down at this blue planet from space, have you ever wondered something? What lies in the very heart of the Pacific Ocean? This vast stretch of sea, the farthest point from any land on Earth, actually has a name. It's called Point Nemo, the most remote location in all the world's oceans. It was identified in 1990 by Croatian-Canadian surveyor Hrvoje Lukotela. Interestingly, he never actually visited the site. Instead, he used computer calculations to determine the point that is farthest from any coastline on Earth. So, rather than a discovery, it's more accurate to call it a calculation. Lukotela named it Point Nemo, combining the Latin word Nemo, meaning no one, with the famous Captain Nemo from Jules Verne's 20,000 Leagues Under the Sea. The exact coordinates vary slightly depending on the method, but according to a 2018 study, it lies around 4,852 s, 1 to 3 to 3W, roughly halfway between New Zealand and Chile. The nearest landmasses are three tiny islands, Ducie Island to the north, Motunui to the northeast, and Mayat Island off the coast of Antarctica to the south. Each of them is about 2,700 kilometers away. You've probably never heard of these islands, and for good reason. Ducie and Mayat are uninhabited islands less than 3 kilometers across, while Motunui is a small islet only about 200 meters wide, located just southwest of Easter Island. That means the closest humans to Point Nemo are either the few thousand residents of Easter Island, 2,700 kilometers away, or the astronauts aboard the International Space Station, orbiting for 100 kilometers above the Earth. To put that distance into perspective, in Japan, the straight-line distance from Miyako Island in Okinawa to Wakanai in Hokkaido is roughly 2,720 kilometers. Imagine drawing a circle with that radius within it. There would be no people and no land at all. Even Easter Island is often called one of the most isolated places on Earth. Yet Point Nemo is more than 2,700 kilometers beyond that and truly the middle of nowhere. So, has anyone ever actually reached it? Surprisingly, yes. Sailors competing in around-the-world yacht races pass near Point Nemo as part of their route. A few cargo ships also occasionally cross the area. Still, visits by ordinary people are almost non-existent. It is the farthest place from civilization, a silent patch of ocean known as Point Nemo, the most isolated spot on our beautiful blue planet. As your ship sails on through the rough, churning waves, you begin to notice something strange. The wind and sea suddenly grow calm. This shift is caused by the Earth's rotation and the presence of a massive ocean current known as the South Pacific Gyre, which circulates counterclockwise between New Zealand, Antarctica, and South America. Inside this gyre, outside winds and currents rarely reach, creating an unusually tranquil stretch of sea. And right at the heart of this vast current lies your destination, Point Nemo. The fastest recorded voyage to Point Nemo by ship took about 15 days and 10 hours 37 minutes. When you arrive, there's nothing to mark the spot, no land, no buoys, no signs of life. All around you stretches an endless expanse of ocean. Because of the curvature of the Earth, no matter how powerful your telescope may be, you will never glimpse land from here. There are no city noises, no crashing waves, only a profound, almost sacred silence. Nowhere else on Earth can one experience such perfect isolation. But don't be tempted to jump in. Point Nemo sits at roughly 49 degrees south latitude, almost the same distance from the equator as Wakanai in northern Japan for Fiven, but on the opposite side of the globe. The sea temperature averages around 7 degrees Celsius 44 degrees Fahrenheit year-round, and the ocean floor lies some 4,000 meters below. Even with a thick wetsuit and full diving gear, survival would be difficult, and if anything went wrong, rescue would be virtually impossible. This extreme isolation also means the ocean here is remarkably barren. Because of the cold currents and the vast distance from land, the water contains very few nutrients, resulting in a striking lack of plankton. And where there's little plankton, there are few fish or any other life. From surface to seafloor, living creatures are almost non-existent. Studies show that the deep waters around Point Nemo contain 1,000 to 10,000 times fewer microorganisms than neighboring ocean regions. For that reason, it's sometimes called the least biologically active region on Earth. Even so, a few pockets of life persist near deep-sea hydrothermal vents. These unique ecosystems rely not on sunlight, but on geothermal energy. Among the creatures found here is the Yeti crab Kaiwaho suta, a ghostly white crustacean covered in fine hair, discovered in the depths near this region. The seafloor here also bears traces of humanity. Because of its remoteness, Point Nemo has long been used as a spacecraft cemetery, where defunct satellites and stations are deorbited safely. The former Soviet Mir space station was among those laid to rest here, and the International Space Station is expected to meet the same fate around 2031. Thus, beneath this silent and lonely stretch of ocean rest the remains of machines that once journeyed through space. A quiet testament to both how far humanity has reached and how far it has left its mark. At Point Nemo, the most remote place on our planet. So, everyone, when you hear the largest fish in the world, what comes to mind? A blue whale? No, that's a mammal. A great white shark? Close, but not quite. The correct answer is the whale shark. Growing up to 20 meters long, this creature is, as its name suggests, a type of shark and a true carnivorous fish. When we think of sharks, we often picture them as gangsters of the sea, fierce hunters that devour anything in their path. So you might wonder, what would happen if a human was swallowed by a whale shark? Let's find out what would actually happen if that were the case. First, let's take a closer look at what kind of animal the whale shark really is. It is the largest fish on Earth, typically reaching about 10 meters in length. It has a flat face, small eyes, and a massive mouth. Its greyish body is covered with white spots that shimmer beautifully against the blue of the ocean. You can see them in aquariums across Japan, and chances are you've already seen one in videos or photos. One of the most fascinating things about whale sharks is their reproductive behavior. While most fish lay eggs and fertilize them externally, a process called external fertilization. Whale sharks use internal fertilization. The male inserts a reproductive organ into the female, much like mammals do. Interestingly, males have declaspers, a feature believed to have evolved from paired pelvic fins. Females, on the other hand, have a unique ability. They can store sperm inside their bodies and use it gradually to conceive multiple times. In other words, a single mating can result in several pregnancies over time. Now, back to our main question, is there any real danger of a human being swallowed by a whale shark? The answer is almost certainly no. That's because whale sharks are filter feeders. They eat plankton and are known for their gentle nature. Their teeth, about 8,000 of them, are tiny and vestigial, no bigger than a grain of rice, and not used for biting or chewing, even if a human were accidentally sucked into its mouth. The whale shark would probably just think, that's not plankton, and promptly spit them back out. But just for fun, let's imagine you somehow shrank small enough to enter a whale shark's body. When feeding, the whale shark sucks in seawater filled with plankton, then filters it through special structures in its throat that separate food from water. Only the plankton remain, condensed and funneled down through the esophagus into the stomach. That esophagus is very narrow, only a few centimeters wide. Even a tiny creature would find it a dark, cramped tunnel. And once it reaches the stomach, it would be broken down by powerful digestive acids. To make feeding easier near the ocean surface, The whale shark often positions its body vertically in the water, so during feeding, its insides are in constant motion, like being trapped inside a stormy washing machine. In conclusion, it's virtually impossible for a whale shark to eat a human. Despite its enormous size, it is peaceful, calm, and harmless to people. A true gentle giant of the sea and the largest fish in the world, the digested food eventually flows into a long tube known as the intestine. This is a world filled with alkaline digestive fluids called intestinal juices. Once the food passes through the stomach, it is further broken down here and ultimately absorbed into the body as nutrients. The traveling digesting matter is now blending into the sea of body fluids, becoming nothing more than nutrients. All they can do is go with the flow of the intestinal juices and make their way toward the exit of this long journey. However, the journey is far from smooth. The interior of a shark's intestine is lined with twisted structures called spiral valves, designed to improve digestive efficiency. As the digesting matter moves forward, it collides with these spiral walls and rotates, tumbling through the passage. It is much like a ball rolling through a giant pinball machine, bouncing and scraping along the way, completely worn out. And yet, another challenge awaits them. Whale sharks are known to perform a behavior called intestinal washing. This involves turning parts of their intestines inside out and exposing them to the surrounding water to flush out any undigested material. If swept away at this point, the long journey would abruptly end. They must cling to the spiral walls and endure no matter what. Eventually, after much time has passed, the remnants reach the very end of the intestine, surviving without being absorbed. Ahead lies the final destination of this long journey, the exit to the outside world. Yes, the body's ultimate exit, the anus. And so, this long journey comes to its end. Having avoided absorption, the remaining matter now exists as a single piece of waste, quietly fulfilling its role until the very last moment. So, when you hear the world's most mysterious sea, what comes to mind? Shakespeare's play The Tempest begins with a storm magically conjured by a spirit, causing a ship to wreck and its crew to reach a remote island. In the play, the region where the ship is lost is described as the still cursed Bermuda. Interestingly, in 1609, a real ship did indeed wreck off the coast of Bermuda, suggesting that Shakespeare may have drawn inspiration from this event. Today, the Bermuda Triangle is known as a historically cursed area. Over the years, there have been numerous reports of ships and planes vanishing without explanation. Some propose far-fetched theories, such as alien intervention or the involvement of the legendary lost continent of Atlantis. So, what really happens if you enter this cursed region? Could you disappear just like the many ships and planes before you? Let's explore what might occur in the Bermuda Triangle. The Bermuda Triangle is generally defined as the area of the Atlantic Ocean bounded by 3 points: Miami in Florida, San Juan in Puerto Rico, and the British territory of Bermuda. What makes this region famous is the sheer number of unusual incidents, ships, planes, and even their crews disappearing under seemingly impossible circumstances. One of the most famous cases occurred in 1945 with Flight 19 during a US Navy training flight. The plane's compasses malfunctioned, and all 5 aircraft went missing. To this day, neither the wreckage nor the 14 crew members have been found. Another well-known case was the disappearance of the USS Cyclops in 1918 while transporting personnel. With 309 people on board, this remains the largest non-combat loss in US Navy history. The exact cause of the accident is still unknown. Even recently, in 2022, an unmanned ship was discovered in the Bermuda Triangle with no crew aboard, as if the people had vanished into thin air. Historically, many lives have been lost in this area. Estimates suggest at least 50 ships and 20 planes have disappeared here, with fatalities possibly exceeding 8,000. So, what really happens if someone enters the Bermuda Triangle? Are they abducted by aliens or transported to another dimension? The truth is far less dramatic. In reality, anyone unfortunate enough to end up here is likely to face a slow and tragic death at sea. Cast adrift in a vast ocean with no land in sight, the person might quietly drown a somber, yet rather ordinary, fate. Despite popular myths, there are no verified reports of paranormal events in the Bermuda Triangle. Most seemingly inexplicable incidents can be explained scientifically. For example, in the case of Flight 19, compass malfunctions are not unusual, and only the lead aircraft experienced serious navigation issues. The crew's inexperience, combined with deteriorating weather, likely caused them to become disoriented over the Atlantic, run out of fuel, and crash. Similarly, the USS Cyclops' disappearance can also be explained by natural causes. The Bermuda Triangle lies along a region known as Hurricane Alley, where storms are common. Even without a hurricane, the warm waters of the area make sudden storms more likely, creating dangerous conditions for ships and planes alike. Some accounts suggest that the USS Cyclops may have sunk after encountering a severe storm. While this is possible, you might wonder why no wreckage has ever been found. There is a scientific explanation for this as well. The ocean currents near the Bermuda Triangle play a major role. In this region flows the powerful Gulf Stream, moving from the southwest to the northeast at an average speed exceeding 6 kilometers per hour. Debris from ships or planes could quickly be carried away by these currents. Combined with the frequent storms in the area, this makes recovering wreckage extremely difficult. There is also a scientific explanation for cases where only the crew disappears. Humans under extreme stress often lose the ability to make rational decisions. If a crew has been at sea for months without adequate food or water, and a storm hits, it is instinctive for humans and many other animals to try to escape danger immediately. Under such conditions, it is not impossible that crew members might abandon ship and jump into the ocean. Other factors unique to the Bermuda Triangle also exist. Compasses generally point toward the magnetic north, but due to the difference between magnetic and geographic poles, some deviation occurs. Experienced navigators can usually correct for this, but in the Bermuda Triangle, magnetic anomalies occasionally cause compasses to point exactly north, confusing even skilled pilots or sailors. A small misreading like this could prove fatal. In short, the Bermuda Triangle is not fundamentally different from other parts of the ocean. Apparent mysterious accidents can be explained scientifically. For example, Flight 19's 1945 disappearance involved compass malfunctions, inexperienced pilots, and worsening weather, likely causing the planes to run out of fuel and crash. The USS Cyclops probably sank due to stormy conditions in a region known as Hurricane Alley, where warm waters can generate sudden storms. So is the Bermuda Triangle genuinely dangerous? Modern technology allows us to track and record nearly all maritime and aviation accidents. Data shows that the number of accidents in the Bermuda Triangle is not higher than in other ocean regions. For example, studies by the World Wildlife Fund suggest that coastal waters near Japan are actually more hazardous than the Bermuda Triangle. Why, then, does the area have such a fearsome reputation? It comes down to human psychology. People naturally struggle to understand probabilities. When our intuition clashes with actual likelihoods, cognitive biases emerge. In the case of the Bermuda Triangle, several biases are at play. For instance, hearing stories about unexplained incidents causes your mind to overemphasize the mystery, an example of the anchoring bias. Dramatic events are also more memorable, leading to overestimation of their frequency. known as the availability heuristic. People might even falsely infer connections between unrelated incidents, called the correlation fallacy. In reality, the Bermuda Triangle is not cursed, and it is no more dangerous than other areas of the ocean. Yet because humans are prone to misjudging probabilities, the region continues to be seen as extraordinary. If one considers the triangle cursed, it is likely a product of stories passed down through generations, cognitive biases, and human imagination, not supernatural forces. The true explanation lies in science, not myth. It is no exaggeration to say that human curiosity has been a driving force behind our civilization's progress. This curiosity is not limited to those working at the forefront of cutting-edge science or technology, nor to viewers of educational science content. It is a trait shared by people everywhere. For example, television programs that travel across the country to empty neglected ponds and showcase the creatures living in them appeal directly to human curiosity. If curiosity knows no bounds, one might wonder, what would happen if we drained an even larger body of water? The largest pond on Earth, of course, is the ocean. What would happen to the planet if all the water in the oceans disappeared? Let us explore this scenario. Even long before humans became aware of it, ocean water has been gradually drained through natural processes. The Earth's surface is covered by layers of rock called tectonic plates, and water is removed where these plates meet in subduction zones. In these areas, denser plates sink beneath lighter ones, and if this occurs under the ocean, deep trenches are formed. The Mariana Trench, for example, was formed through this type of subduction. Even long before humans became aware of it, ocean water has been gradually drained through natural processes. The Earth's surface is covered by layers of rock called tectonic plates, and water is removed where these plates meet in subduction zones. In these areas, denser plates sink beneath lighter ones, and if this occurs under the ocean, deep trenches are formed. The Mariana Trench, for example, was formed through this type of subduction. The process does not involve empty spaces. Instead, high pressure causes chemical reactions between the rocks of the sinking plate and seawater, creating new types of rock. These rocks are weaker than the original, so they deform and sink further. While there is some debate, many scientists believe this process consumes water in subduction zones. This cycle has been ongoing for millions of years, and a significant amount of water is thought to be stored within the Earth, chemically bound to rock. The exact volume of water trapped inside is not fully known, but estimates suggest it may exceed the total amount of water on the Earth's surface. Studies indicate that over the past 230 million years, water subducted in this way may have caused sea levels to fluctuate by around 130 meters. One might worry that if this process continues, the oceans could eventually dry up completely. However, this is not the case. Depending on the type of rock, when it reaches the mantle, chemical bonds become unstable and water is released, returning to the surface through volcanic activity. Near the surface, evaporation, cloud formation, and precipitation complete the familiar water cycle. In addition, this deeper cycle forms a larger global water cycle, ensuring that ocean water is never truly lost. But what if human curiosity intervened further? What if we tried to drain all the ocean water? As the title suggests, let us imagine removing all the water from the seas. Immediately, nearly all aquatic life would perish. Fish cannot breathe without water, and algae, plankton, whales, dolphins, and countless other species depend entirely on aquatic environments. On what was once the seafloor, their bodies would lie scattered. The total carbon contained in Earth's aquatic organisms is estimated to be around 6 billion tons. Assuming an 18% carbon content similar to humans, with a density of 1, this corresponds to approximately 333 cubic kilometers of biomass. The oceans cover 361 million square kilometers, so the average thickness of dead organisms now lying across former ocean floors would be about 9 millimeters. In reality, the density of life varies depending on the location. Generally, areas closer to land and shallower waters tend to have more life, while tropical oceans have fewer organisms. This means that in some places, such as the previously studied Point Nemo, very little would accumulate, whereas in areas like off the coast of Alaska, enormous amounts of organic matter have built up over time. Consequently, a large-scale decomposition of these remains would occur almost immediately. However, this process would not last indefinitely. With the complete cessation of the water cycle, rainfall would stop entirely. The remains accumulated on the seafloor would eventually dry, possibly being preserved in a partially decomposed, mummified state. The effects would not be limited to aquatic life. With no rain, terrestrial organisms would gradually suffer dehydration and die as well. The situation would be further complicated by an unprecedented drop in humidity. Even plants adapted to dry conditions, such as cacti, require some moisture. In extremely low humidity, they too would weaken. Most land organisms would perish, and the extremely dry air could trigger global-scale wildfires. This would release massive amounts of carbon dioxide into the atmosphere, accelerating global warming. Formerly land-covered areas would be scorched, and previously oceanic regions would be covered with mummified remains, a catastrophic scene. Nevertheless, this would not immediately cause the total extinction of life on Earth. Life exists not only on land and in oceans, but also deep underground. Some studies estimate that roughly 13% of all biomass resides beneath the surface. These subterranean organisms rely on water stored within the Earth and would be largely unaffected by the loss of surface water. Over time, some of this life could re-emerge and recolonize the surface. The exact timing of life's first appearance on Earth remains uncertain. Estimates based on genetic mutation rates suggest life may have originated as far back as 4.5 billion years ago. During the late heavy bombardment, approximately 4.1 to 3.8 billion years ago, frequent asteroid impacts may have temporarily heated the Earth's surface enough to eliminate oceans. Yet life in the subsurface would have been relatively insulated and could survive until surface conditions stabilized. Unlike that ancient scenario, the complete removal of surface water in this thought experiment would leave substantial water still stored underground. While the surface water cycle would be destroyed, the global water cycle, involving the Earth's interior, would continue, gradually replenishing the surface through volcanic activity. Ultimately, the fate of Earth would depend on the rate of ongoing global warming relative to the rate at which water is restored to the surface. If surface water exists, clouds can form, reflecting sunlight and eroding rock, which returns carbon dioxide to the lithosphere. If global warming proceeds too quickly, surface temperatures could rise to levels incompatible with liquid water, resulting in irreversible changes. Scientists also note that without oceans, plate tectonics might halt, leaving the effects of volcanic activity uncertain. This hypothetical scenario highlights how delicate the balance of Earth systems is. While catastrophic for humanity and most surface life, life deep underground could endure, potentially recolonizing the planet over time. In the end, the Earth itself would persist, but the surface ecosystem would face a dramatically altered reality. The largest ocean on Earth, the Pacific, is so vast that it can be almost unimaginable. From a point off the coast of Peru in South America, the farthest place on Earth, the point directly on the opposite side of the planet, lies in the same Pacific Ocean. Off the coast of Vietnam in the South China Sea, moreover, the central Pacific has almost no land, stretching out as an endless expanse of open ocean. For those with a sense of adventure, setting out into the Pacific might feel exhilarating. However, in reality, many people have accidentally drifted far from land and ended up stranded in the Pacific. If you were left alone in a small boat on the Pacific, what would you experience? Could you survive? Here, we'll explore what happens when someone becomes lost at sea in the Pacific. If you are carried away by the ocean, where might you end up if you do nothing? Generally, the world's oceans are made up of circulating currents called gyres. In the Pacific, there are the North Pacific Gyre and the South Pacific Gyre, with the Kuroshio Current near Japan, flowing from southwest to northeast, being part of these systems. If you drift with the currents, you are likely to follow their general direction. Starting from near Japan, you would drift eastward toward the coast of California. However, you would not endlessly travel back and forth within the currents. The centers of the gyres are known to have very little current, and anything that reaches these areas tends to remain there. A person adrift could ultimately end up in one of these zones, where they might remain essentially stationary. With little wind and calm seas, one could spend their life quietly observing the ocean around them. This phenomenon does not only affect drifting people. It also applies to trash that humans release into rivers and oceans. One such area in the North Pacific is known as the Great Pacific Garbage Patch, located between southeastern Japan, Hawaii, and California. It is estimated that just the region between Hawaii and California contains roughly 79,000 tons of human-generated debris, with recent studies suggesting that this amount is increasing rapidly. However, much of this debris floats below the surface rather than on top, meaning the density is not as high as the name garbage patch might suggest. For someone drifting there, it may not feel noticeably different from other parts of the ocean. In any case, it is likely that a person adrift could spend their life quietly in this area. Yet, the fact that debris tends to accumulate in the garbage patch is only a general pattern. Not everyone will end up there. For example, after the 2011 Great East Japan earthquake, some debris carried into the ocean was later found along the west coast of the United States. What would it be like to drift and become stranded in the open ocean? Surviving more than a few days alone is extremely difficult. One major factor is water temperature. Cold water draws heat from the body, causing hypothermia and potentially death. In general, the colder the water, the shorter the survival time, approximately 1 hour at 5 degrees Celsius, 2 hours at 10 degrees Celsius, and 6 hours at 15 degrees Celsius. Water temperatures above 25 degrees Celsius are generally considered safe for avoiding hypothermia. However, even in Okinawa, the sea exceeds 25 degrees Celsius only about half the year. During the winter in Japan, survival for more than a few hours would require drifting near the equator or in the southern hemisphere. Otherwise, unconsciousness and death could occur quickly. Even in warm waters, survival is not guaranteed without rescue. In 1998, a couple in Australia drifted while wearing wetsuits and life jackets. They survived for about a day but eventually drowned due to dehydration and fatigue. For those in a boat, water temperature may not pose a major risk, but dehydration remains a serious concern. It may seem strange to become dehydrated while floating on water, but it is important to remember that this water is not fresh, it is seawater. Because seawater contains a much higher salt concentration than human blood, drinking it forces the body to expel the excess sodium it takes in. That job falls to the kidneys, which filter the blood and release the extra salt through urine. However, the kidneys have their limits. In order to remove that salt, they must use up a large amount of water from the body. According to one study, drinking just 100 milliliters of seawater can cause the body to lose about 175 milliliters of water through urine. In other words, trying to quench your thirst with seawater only makes dehydration worse. That's why securing a source of fresh water becomes the top priority in any survival situation. If you have a plastic container, tarp, or any waterproof clothing on board, they can be used to collect rainwater, one of the few safe ways to hydrate at sea. Of course, rain doesn't always fall when you need it. Some survivors who were stranded in the Pacific have reported finding other, more desperate sources of drinking water, such as the blood of sea turtles. Sea turtles are relatively easy to catch, and because their blood has a lower salt content, it can serve as a vital source of fluid in emergencies. In addition, small fish often gather in the shadow of a drifting boat. If you have any sort of fishing gear, catching them can provide a critical food supply. In the end, survival at sea often means being willing to capture turtles or fish and to make hard choices to stay alive. A striking real-world example occurred in 2012 when Mexican fisherman Jose Salvador Alvarenga was caught in a storm and lost power to his boat. He drifted for roughly 438 days, more than 10,000 kilometers, before washing ashore in the Marshall Islands. It remains one of the longest confirmed survival drifts in human history. Japan also has its own record of such endurance. During the Edo period, a sailor named Kikitsugi Hichio Kichi was blown off course by a storm and drifted across the Pacific. After 484 days, he and only two crewmates survived, reaching waters near the American continent. This extraordinary voyage is still recognized by the Guinness World Records as the longest drift ever recorded. Stories like these might make some people dream of taking on the vast ocean themselves, just a small boat against endless blue. But in reality, countless others have vanished without a trace on that same Pacific expanse. Even Alvarenga himself began his ordeal with a companion who eventually gave up hope, refused food, and lost his life before rescue ever came. In the open sea, survival depends not only on luck or skill, but on will, the strength to keep living when you have no idea where you are, which way you're drifting, or whether help will ever arrive. So ask yourself, do you have the will to survive? Belize, a small country located south of Mexico, is only about 1.2 times the size of Shikoku in Japan. Yet it is famous for the largest coral reef in the northern hemisphere, the Belize Barrier Reef. When viewed from the air, the reef stretches across a vast expanse of emerald green water, with a circular deep blue area standing out. This area, which looks as if a giant hole has opened in the sea, is known as the Great Blue Hole. For those interested in falling or diving experiences, such a location is hard to ignore. But what would it be like to actually fall into the Great Blue Hole? What awaits at the bottom of this underwater sinkhole? In this article, we explore what happens when one descends into the Great Blue Hole. The Great Blue Hole appears deep blue because its water is much deeper than the surrounding shallow sea. Similar formations exist worldwide and are referred to as blue holes. The Great Blue Hole in Belize is one of the most representative examples. It has a maximum depth of approximately 120 meters and a diameter of around 300 meters, forming a shape close to a cylinder. While the deepest blue hole in the world is the Dragon Hole in the South China Sea, with a depth of about 300 meters, the Great Blue Hole holds the record for its diameter. Viewed from above, it is nearly perfectly circular, giving it an exceptionally beautiful appearance. There are several theories about how blue holes form, and in the case of the Great Blue Hole, it is believed to have originated as a limestone cave during an ice age when sea levels were lower than today. After the cave's roof collapsed, rising sea levels at the end of the ice age caused seawater to fill the cavity, creating the formation we see today. Before imagining a fall into this hole, some caution is necessary. The Great Blue Hole is known as one of the world's premier diving spots, but typical scuba diving only reaches depths of several tens of meters. With a depth of 120 meters, it is clear that this is not a place one can casually descend into. If one were to fall from the center of the hole, there is a chance of encountering large sharks, such as hammerhead sharks, Caribbean reef sharks, or bull sharks. However, until reaching the bottom, one would likely see few unusual creatures. On the other hand, falling from the edge of the hole offers a different perspective. The edge slopes gently and is covered with a rich coral reef. Some of the life found here includes brightly colored butterflyfish and angelfish, cleaner shrimp waving their antennae among the sea anemones, graceful sea turtles, and shallow water sharks like nurse sharks and Caribbean reef sharks, representative marine life of the Caribbean Sea. However, this vibrant scenery suddenly ends at about 15 meters deep. The gentle slope becomes a cliff, giving way to the abyss-like deep sea beyond. Falling along this cliff, one sees a sharp drop in the number of visible creatures, except for some that cling to the cliff face. Around 20 to 30 meters deep, the water temperature drops sharply from roughly 30 degrees Celsius to about 26 degrees Celsius, entering a zone where water circulation changes dramatically. This is a phenomenon rarely seen in the Caribbean and is caused by the minimal water flow within the Great Blue Hole. Looking further south along the wall, you can spot the entrance to a cave between 30 and 45 meters deep, where stalactites and stalagmites form shapes that resemble a shark opening its mouth. The largest of these stalactites can reach up to 12 meters in length and 60 centimeters in diameter. Because stalactites and stalagmites do not form underwater, their presence serves as evidence that the Great Blue Hole was once above sea level. Interestingly, some of the stalactites, which should naturally grow straight down, are tilted between 5 to 12 degrees. This is believed to have occurred after the initial formation, when tectonic shifts caused the surrounding land to tilt. Descending further to a depth of around 50 meters, you can see another cave entrance on the western wall. This cave extends roughly 50 meters horizontally, and remains of sea turtles have reportedly been found inside. At this depth, larger marine life becomes scarce, but smaller creatures hiding in the holes along the wall are still present. Around 90 meters deep, conditions change dramatically. The water temperature, which had remained around 26 degrees Celsius, drops sharply to about 22 degrees Celsius. However, the main challenge is not the temperature. Directly below, a brown, mist-like layer appears. This layer contains high concentrations of hydrogen sulfide, a toxic substance, and covers much of the area around 90 meters deep. Beneath it, light barely penetrates, and oxygen is virtually non-existent. At the seafloor, around 120 meters deep, you might see what is sometimes called a conch graveyard, where shells of conchs and hermit crabs have ended up after suffocating in the oxygen-depleted water. The abyss-like nature of this environment is thus very real. The lack of oxygen in this layer is likely due to the decomposition of organic material, which consumes the available oxygen. Bacteria that break down organic matter in anoxic conditions often release hydrogen sulfide as a byproduct, which accumulates at this depth. As a result, no living animals are observed in this zone. During a 2018 exploration, two human bodies, along with bottles and cameras, were discovered in the Great Blue Hole, having gone missing previously. These, like other debris, are expected to eventually be buried by sediment. In fact, it is theorized that the Great Blue Hole itself could eventually fill with mud and become a shallow area. To date, only 2 expeditions, including the 2018 exploration, have reached the bottom of the Great Blue Hole, having made it to the seafloor. One might consider further exploration. While there is no scientific evidence, some speculate that tunnels might exist connecting the Blue Hole to the Belize mainland. Alternatively, one could simply remain at the bottom, slowly being covered by sediment over time, experiencing the passage of ages in silence.